Welcome. In this video, we tackle factoring polynomials. We are in day 2 of Unit 5. We're in section R5 of the book, and we will cover the first 5 objectives. The first one, factor the difference of two squares, but not the sum or difference of two cubes. We will factor perfect squares, factor a second-degree polynomial, factor by grouping, and factor a different kind of second-degree polynomial. All right, we have a lot to do, and a lot of times in these lessons I ask you to pause and try and then start it up again when you're ready to check your work. I won't say that explicitly in this video, but do it a lot. There are lots and lots of problems, and so give yourself the practice that you need to feel comfortable with these things. All right, let's get started. First of all, factor out a monomial. A lot of times we have sums of 2 or 3 things, and there's a common factor in each term. What is the common factor? So let's give this a try. So for the first one, I see 2 and 4, so it looks like there's a common factor of 2. I can factor a 2 out, and I get x plus 2. Here there's a common factor of 3. 3 times x minus 2. How about here? Well, I won't have a factor of x or anything because one of my terms only has an 8. So the biggest number that goes into everything is 2 again. So 2 times maybe x squared minus 2x plus 4. What's the next one? Can I factor out an 8? No, not an 8, but maybe a 4. 4 times 2x minus 3. How about this guy? Well, there aren't any numbers I can factor out, but there is a factor of x that's common to both terms. So x times what? How about x plus 1? And now what? Not only is there one x, there's actually 2 x's that are common to both terms. So I can factor out an x squared. And so from this first term, what's left is x, and from the second term, minus 3. And lastly, now I can factor out both a number and an x. At least it looks like between 6 and 9, there's a 3 in common. And between the x squared and the x, there's 1x. So how about 3x? And that leaves me with 2x plus 3. Now, how about dots? The difference of two squares. Look at the different problems that we have. These all fall under the dots category, difference of two squares. And we might approach this factoring problem backwards. Let's look at this product. We've seen this product before. A plus b times a minus b gives me the difference of two squares. So if I see something that's the difference of two squares and I don't know where it came from, I have to figure out how to write it. And I will write it like a plus b times a minus b. Oh, for example, let's go ahead and get started. X squared minus 9. On the left, it's the x that's being squared, and on the right, it's the 3 that's being squared. So x plus 3, x minus 3. How about the next one? X plus 1, x minus 1. And if you're ever in doubt, you want to double check, use the formula for multiplying, or just use FOIL, and you can confirm your answer. This next one's a little bit tricky. This x to the 6, that doesn't really look like a square, is it? But then you might remember, if I take x cubed and I square it, I end up with x to the 6. So that's the thing that's being squared on the left. And the 16, well, that's the square of 4. So I have an x cubed squared and I have a 4 squared. So that looks like x cubed plus 4, x cubed minus 4. All right, next problem. Is that the square of something? That is actually 3x being squared. And then, of course, 100 is 10 squared, so 3x plus 10 and 3x minus 10. And this last one, all right, 36x squared. So maybe 6 and then x, and that's what's being squared on the left, and 81 is the square of 9. So 6x plus 9 and 6x minus 9. A related problem is perfect squares. So look at this multiplication problem. When I have a binomial, a plus b, and I square it, you can use FOIL to get a result of this form, a squared plus 2ab plus b squared. The trick is to look for things that are perfect squares on the two ends, at the beginning and the end. And then maybe the guy in the middle is twice the product of the a and the b. Let's see how this works in practice. All right, in my first problem, I have x squared and I have 9, and that's the right form, so they're both squares. And so I think maybe the answer is x on the left and not 9. How about 3 on the right? And is that true? Now, just to double check, I really need to make sure that the 6x works all right. So if I multiply the x and the 3, I get 3x, and if I multiply that times 2, I get 6x. Yep, so I had 6x in the middle, I get 6x there. Check, that works. How about the next one? X squared minus 6x plus 9. So I check x squared is a perfect square, 9 is a perfect square, so x on the left, 3 on the right. But now, I mean, I can't have plus because that would give me the same answer as before. And look, there's a minus sign in there. Could it be minus 3 and then square the whole thing? I think so, because now the product of a times b is negative 3 times x, so negative 3x. And if I multiply that times 2, I get negative 6x, which is what I have in the middle. So that looks good. So when you see that negative, that means we have x minus something being squared. All right, let's see. Perfect square on the left, perfect square on the right. So how about 5x on the left? 5x is the square root of 25x squared, and 3. And I have a plus before my middle term, so I'll want the plus there. And let's just confirm. Oh, put a square. 5x times 3 is 15x. And then if I double that, I get 30x. Which is good. That's what I have in the middle. All right, last one. 9x squared and 1. So I bet I'm going to start off with a 3x, and I'll end up with a 1. There's a minus sign in front of the 6, so I bet I'm going to want a minus. And let's just double check. 3x times 1 is 3x. Whoops, 3x times a negative 1 is negative 3x. And then if I multiply that by 2, I get negative 6x. And that's exactly the middle term there. So check, looks good. Factoring trinomials, x squared plus bx plus c. We'll spend a lot of time on this particular form. It comes up a lot. So working it backwards, let's do the product. If I start off with something of the form x plus a times x plus b, and if I use FOIL, I end up with x squared plus a plus b x plus ab, the product at the end. Here's an example. Let's say I multiply x plus 3 times x plus 4. By FOIL, the first is x squared, the outside gives me 4x, the inside gives me 3x, and the last makes 12. When I add the 3x plus the 4x, I get 7x. So I see that the 12 is the product, 3 times 4, and the 7 is the sum, 3 plus 4. In general, in these problems, we'll be given a polynomial that looks like that. And I have to figure out what are the two numbers that make a product, that is the constant term on the right, and whose sum is the coefficient in the middle. Let's see some examples. All right, let's factor x squared plus 9x plus 14. I need two numbers that multiply to 14 and add to 9. I could try 1 and 14, but 1 times 14 is great, but they don't add to make 9. 2 times 7, there we go. 2 times 7 makes 14. 2 plus 7 is 9. So my solution is x plus 2, x plus 7. How about the next one? Two numbers that multiply to make 21 and add to make 10. 3 and 7, I think that works. 3 times 7 is 21, 3 plus 7 is 10. So there's my solution, x plus 3, x plus 7. All right, moving on. Let's look at the 20. two numbers that multiply to make 20 and add to make 9. Well, there's 1 and 20, 2 and 10, 4 and 5. Oh, there we go. I hit it. 4 and 5. So x plus 4, x plus 5. How about the next one? I need two numbers whose product is 20, whose sum is 21. How about just 1 and 20? That will work. So I get x plus 1, x plus 20. Moving on, okay, 13, I think this is the same situation. The product has to be 13 and the sum has to be 14, so maybe 1 and 13 will work out really well for us. X plus 1, x plus 13. And the last one, two numbers whose product is 100 and sum is 29. Okay, well, what makes 100, I guess? 2 times 50, 4 times 25. Oh, that'll work. 4 times 25, because 4 plus 25 is 29. So x plus 4, x plus 25. So same theme, we'll do some more problems, but this time the big difference is instead of having plus plus, I have plus minus. How does that happen? Well, the product is now negative 21. Say I have a positive 7 and a minus 3. And with that positive 7 and minus 3, I get my positive 4. So it's like I'm adding 7 and subtracting 3. So here's how I think about this. Whenever there's a minus in front of this number at the end, I need two numbers whose product is 21, but I need to add and subtract them somehow to get 4. So I might start off thinking 7 and 3 will give me 21, but then in order to make 4, I need that to be a positive 7 and a minus 3. Let's see how this works in these problems. All right, first example, negative 8. So 2 and 4 could be good, but 2 plus 4, 4 minus 2, 2 minus 4, none of those are going to give me 7. So how about, so not 2 and 4, 1 and 8. 1 and 8 will work, but the 8 needs to be positive and the 1 negative. So positive 8 minus 1. So let's make that x minus 1, x plus 8. Therefore, the product is negative 8, and the sum is a positive 7. All right, same kind of problem again. I still have the negative 8, but now the two terms need to add or subtract to make 2. Oh, you know what? The 2 and 4 that I had before is going to work well. So 2 times 4 is 8. How do I add or subtract to make positive 2 if I have positive 4 and negative 2? So x plus 4, x minus 2. All right, next problem. I need a negative 10. So 5 and 2 give me 10. The product of 5 and 2 is 10. Can I somehow work out a 5 and a 2 to get negative 3? Yeah, if I have a positive 2 and a minus 5, that'll give me a negative 3. So I can write x minus 5, x plus 2. All right, negative 15. Oh, negative 14 is so close to it, I'll bet the factors I want are just 1 and 15. Now, I want negative 14, so I bet I need to subtract 15 and then add 1. So minus 15 plus 1, that'll give me a negative 14. So x plus 1, x minus 14. Negative 28. What makes negative 28? Well, 7 and 4. We'll say 4 and 7. Can I work 4 and 7 to make 12? 4 plus 7 is 11, and I can't add or subtract to make 12. Okay, so 4 and 7, that's not going to work. I need something else. How about 2 and 14? Will 2 and 14 work? Ah, yes! If I take a positive 14 and a minus 2, so I add 14, I subtract 2, that'll give me the positive 12. So my factorization is x minus 2, x plus 14. Okay, last one. Negative 100. And somehow I need to get a negative 15. So 2 and 50. No, that's not going to work. 4 and 25. I can't add or subtract 4 and 25 to get 15. 5 and 20, maybe that works. That works. I need negative 15, which means I probably want negative 20 plus 5. So the factorization, x plus 5, x minus 20. One more situation where I have this same kind of trinomial. In this case, our two factors both have minuses on them. And so look, once again, there's a positive constant term at the end, but the difference is now with this positive constant term, I have a minus sign in the middle. So when I approach this problem from the beginning, I think to myself, I need two numbers that multiply together to make 21. 7 and 3, 3 and 7 work. So how will I manipulate 3 and 7 to get negative 10? Oh, well, I actually need negative 3 and negative 7. But that's okay to make both of them negative, because negative 3 times negative 7 is still positive 21. But negative 3 minus 7 is the negative 10 that I need. All right, let's try these problems now. In all of these situations, notice I have the negative before my middle term and the positive before my last term. All right, so two numbers whose product is 10. How about 2 and 5? 2 and 5, 2 times 5 is 10, and negative 2 minus 5 is negative 7. So the factorization is x minus 2, x minus 5. All right, 18. What makes 18? 2 and 9. And, 2 plus 9 is 11, so negative 2 minus 9 is negative 11. So x minus 2, x minus 9, that will work. 7. It looks like, since my middle term is 8, I'm probably just going to want 1 and 7. Well, negative 1, negative 7, right? X minus 1, x minus 7. Last problem. Two numbers whose product is 30. Well, 1 and 30, 2 and 15. Oh, 2 and 15, I bet is going to be nice. That looks close to 17. So subtract 2, subtract 15. That'll give me negative 17. There we go. X minus 2, x minus 15. All right, we've spent a lot of time with this kind of trinomial, where the x squared has a coefficient of 1, and the x has some number coefficient, and the c is some number. Those come up often, so be sure you give yourself some good practice with those types. Now we'll move on, and the next category is factor by grouping. This is a situation where we have 4 terms. Suppose I have x cubed minus 4x squared plus 2x minus 8. How will I factor this? And the trick with factor by grouping is group the two pairs of terms. Group the first 2 terms and then group the last 2 terms, and see if you can factor something out of that. The first 2 terms, is there a common monomial factor there? I think it's x squared. And the second 2 terms, is there a common monomial factor there? I think we can pull out a 2. So pulling an x squared out of the first gives me x squared times x minus 4. Pulling 2 out of the second gives me 2 times x minus 4, and a beautiful thing happens. I have a common factor of x minus 4 there. So this means I can pull out the factor of x minus 4, and I'm left with x squared plus 2. That's the x squared and the plus 2 over there. Let's do some more examples. By grouping, all right? What can I pull out? Maybe from the first pair, 4x. So you want to pull out as much as you can. That leaves me with x plus 2. And how about the next pair? What can I pull out? Well, just a number, right? And I can pull out a 3. And that leaves me with x plus 2. And I'm glad to see this, x plus 2, x plus 2. It means I'm on the right track. And what I've pulled out is the 4x plus 3. So 4x plus 3 times x plus 2. There we go. All right, next one. Let's group first 2 and last 2. in my first two terms, looks like I can pull a 3 as a number, and the x's, I can pull out 1x. And that leaves me with 1x there minus 2. And, oh, I can't pull anything out. It just stays x minus 2. That's okay. X minus 2. So I have a 3x times x minus 2 plus x minus 2. Maybe you could think there's really a 1 in there. So this becomes 3x plus 1 times x minus 2. Last problem. Let's group the first two terms, group the last two terms. What can I pull out? All right, as a number, I think I can pull 3 out again. So 3. And then how many x's? I can pull out 1x. And that leaves me 5x plus 4. Plus, I can pull out a 2. And I'm hoping, right, you can kind of get a sense of where we're going on this. I'm hoping that I'm going to see a 5x plus 4. Is that going to match 5x plus 4? Yep, there it is. Pull them all together. 3x plus 2 times 5x plus 4. Our last category is factoring trinomials, where all three terms have coefficients in front of them. And I pulled the little paragraph out of the book. I thought it was a nice demonstration. We'll go through the method, and as we go through the method, we'll try to solve factoring this particular trinomial on the bottom. All right, let's start. So step 1 says find the value of a times c. Remember, capital A is the coefficient on the x squared. C is the constant. So in the example, A is 14, C is 3. So my AC, 14 times 3, that's 42. Okay, I figured out A times C. Check. Step 2. Find a pair of integers whose product is AC and that add up to B. B, for me, in this problem, is 23. So I need to find factors of 42 that add up to 23. Well, right from the beginning, this AC, I know two factors of 42. I know 14 and 3. Those will multiply to make 42. But if I add them together, I don't get 23. So I need to keep looking. Well, of course, 1 and 42, those are two factors of 42. But they do not add to 23 either. How about 2 times 21? 2 times 21 is 42. And look at that. That looks nice. 2 and 21, those are the two numbers I need because they add up to make 23. All right, so step number 2, check. Oh, and they call those little a and little b. So my little a is 2, little b is 21. Step 3, write ax squared plus bx plus c, that's just my original expression, ax squared plus bx plus c, as ax squared plus little ax plus little bx plus c. Okay, so this becomes 14x squared plus 2x plus 21x. So I've just split up the 23x plus 3. All right, check. Step number 4. Factor this last expression by grouping. Oh, well, let's give it a try. All right, I will group the first two terms, group the last two terms. What can I pull out? I can pull out a 2 and an x, 2x. And that leaves me 7x plus 1. And from my next two terms, I can pull out a 3. And that leaves me with 7x plus 1. Oh, 7x plus 1, 7x plus 1. That's fantastic. So the answer is 2x plus 3 times 7x plus 1. Another example. Let's factor 2x squared minus 6x minus 36. Now, you might be tempted to say, okay, multiply the first and the last, a and c. 2 times 36 equals 72. But wait, there's something else that we should do first. Did you notice that 2, 6, and 36 all have a common factor of 2? So actually the first thing I should do is factor out the 2. So 2 times, and I'm left with x squared minus 3x minus 18. And this becomes a simpler problem. So instead of having to go through the complicated, all the steps, this is actually one of my forms that I saw earlier. So how do we factor this? I need 2 numbers that multiply to make 18. So how about 9 and 2? But they have to add or subtract to make 3. Well, I can't do that with 9 and 2. Maybe 6 and 3. Oh, and that should work, right? Okay, so I have a negative there. So one of these signs is going to be positive. One of these will be negative. And I need to make a negative 3. So how about a plus 3 minus 6? That should give me a negative 3. So the 2 stays there. But now I have x minus 6 and an x plus 3. There we go. So this isn't really a problem of the form that I was working at. It was just one of our simpler problems in disguise. So let's go back. Here's a real example. Let's factor 3x squared plus 5x minus 12. And quick check, 3, 5, and 12, they don't have any common factors, so I really do need to use the strategy here. Okay, AC. AC is the product of the first and the last. 3 times 12, that's 36. Give me 2 numbers whose product is 36 and that have a sum of 5. I don't think I can do it, right? 1 and 36, 3 and 12, 2 and 18, 9 and 4. If I add these things together, none of them add up to give me 5. I've made a mistake, right? I know I made a mistake. Do you see the mistake I made? The mistake I made is that AC isn't really 36. What I really need to do is make that negative 12 times 3, so AC is really negative 36. So I need 2 numbers that multiply to make negative 36, and then they add or subtract to make 5. So down here is going to work, because positive 9 minus 4, that makes 5. And positive 9 times negative 4, that gives me negative 36. All right, now I can write out 3x squared, and what am I going to do? I'll take this 5x and I'll split it apart. Let me put the negative 4 first. Minus 4x plus 9x, and then minus 12. All right. It is nice to put the positive sign in the middle, and here's why. Because now when I group, I have a positive that goes in front of the group. I don't need to just distribute any negatives. And let's pull out some common factors. So out of the first 2 terms, it looks like I can pull out simply 1x. And that leaves me 3x minus 4. Out of my next 2 terms, I can pull out a 3. And that leaves me 3x minus 4. Oh, great. 3x minus 4 appeared 2 times. And so I can write the quantity x plus 3 times 3x minus 4. Let me not leave this example too quickly. There's something I want to show you. Suppose that I had found the positive 9 and the negative 4, but I didn't put them in this order. What if I switched the order? I could say 3x squared plus 9x minus 4x minus 12. That's okay. That looks good. And I can group the first 2 terms fine. But something bad happens if I try to group the next 2 terms. If I just write that, that is wrong. Because if I see negative in front of parentheses in front of a group, I have to distribute that negative. If I were to take away the parentheses, I'd end up with a positive there. So what I need to do is, if I have the negative in the middle, I need to change the sign of the guy down there. And that looks okay, because now if I were to distribute the negative sign, I would end up with minus 4x minus 12, which is truly what I have without the parentheses there. Okay, so it is just one little wrinkle that gets added if you decide to put your minus sign in the middle. Let's continue. From the first 2 terms, I can pull out 3x. 3x, and that leaves me x plus 3 minus, from the next two terms I can pull out a 4, and that leaves me x plus 3, and so I have 3x minus 4 times the quantity x plus 3. And this is interesting. I've ended up at the same final answer, but my two factors have switched places. That's what happens when you switch the two places of the inside terms. All right, let's leave this with two final examples. So if you would like to pause and try, I encourage you to do that. See if you can factor these two trinomials. Otherwise, here I go. I'm going to work them out. In the first case, AC is 2 times 3, that's 6. I need factors of 6 that add up to 5. Oh, so how about 2 and 3? I'll put them off to the side. 2 and 3. 2 times 3 is 6, and 2 plus 3 is 5. So I want 2x squared plus 2x plus 3x plus 3. I will factor by grouping. In my first case, I can pull out a 2x, and that leaves me with x plus 1. In the second case, I can pull out a 3, and that leaves me with x plus 1. Oh, good. I'm always hoping I'm going to see that same factor both sides. And so my solution is 2x plus 3 times the quantity x plus 1. All right, last one. 2x squared minus x minus 6. Product of the first and the last 2 times negative 6, so negative 12. Two things that multiply to make negative 12, add or subtract to make negative 1. 3 and 4 look pretty good because they're only 1 apart, so 3 and 4. Do I want positive 3, negative 4, or do I want negative 3, positive 4? Well, this guy has to be negative in the middle, so how about positive 3 and negative 4? So I'll write 2x squared. You know what, I'm going to put the negative first. Negative 4x plus 3x. That kind of gives me the plus sign right in the middle of everything, which is nice. So now I can group, factor each pair of terms. So from the first pair of terms, it looks like I can factor out a 2x. 2x times the quantity x minus 2. Now what? From the next two terms, looks like there's a 3 in common. X minus 2. Looks good. I like that. And I'm left with 2x plus 3 times x minus 2. All right, there we go. If you are watching this and listening to me now, you have made it to the end of this video. Well done. I know this was a long video. This factoring, it is a skill. It just takes lots of practice. But in a certain way, I hesitate to say enjoyable, but it's a puzzle. You know, think of it as a puzzle. Each factoring problem is a little mini Sudoku or a crossword puzzle. Think of it as a challenge. Challenge yourself to see that you can get to the end of it. It's a mystery. You know, this polynomial is written out. It's hiding a secret. The secret is, what is the factorization? Treat each problem like a little puzzle and see that you can get through it. And it takes some cleverness. So exercise your cleverness with these problems, and I will stop here.